Hello, ladies and gentlemen. I hope you are all doing fine. I would like us to look at something different from what we've been looking at. We've been looking at graphs and tables to summarize our data. At the moment, I would like us to look at summary statistics, and we'll spend quite some time looking at this. Now, we are going to first of all look at measures of the center, sometimes measures of central tendency. A measure of central tendency is a value used to represent a typical or average value in a data set. So when you have a set of observations, you want to check what is a typical value that I can identify in this data set, which I can use as a summary for the entire data set. So there are 4 values that are considered measures of the center. We have the mean, which we can also call the average, so the arithmetic mean. We also have the median, the mode, the mid-range, and we're going to describe each one of those. So here we are going to look for measures of tendency for raw data. Suppose you are weighing babies born at your clinic somewhere in Malawi, and the baby weights in kilogram of the first 10 babies were as follows. So the first baby weighed 2.7 kilogram, the second one 3.4, up to the last one, the 10th one, weighed 3.0 kg. What single figure could represent the baby weights at this clinic? If you were to choose a single figure that is almost close to reality in terms of representing the baby weights at the clinic. In most of the time, we say, on average, what could be the baby weights for babies born at that particular clinic? So let's see how different measures of central tendency are computed. First of all, we start with the mode. And I should mention that most of these measures, you did encounter them at your secondary education, during your secondary education. So I think it should be a little bit easier for you to understand. So the mode is the data value or datum or value, which appears the largest number of times in the data set, or the most frequently occurring figure in the data set. So if you have a number of observations, then you see which one is most frequently appearing. Let's look at this data set. The one we looked at, 2.7 kg, 3.4, 3, 4.1, which is the most appearing number in this set. So if you look at this data, you find that 3 is appearing here. It's also appearing there. It's appearing there. So 3 is appearing 3 times, and there is no any other number that is appearing more than those times. Actually, most of them are appearing only once. So then the highest appearing number, the most frequent occurring figure is 3. So 3 is our mode when we consider this set of observations. Let's look at the median. So the median is defined as the middle figure after the data set is ranked or placed in order of magnitude. So you recall for the mode, we just looked at the set of observations as they came. But for this, we need to do something before we identify what the median is. So we need to arrange those observations from the lowest to the highest. So the median M of a set of n observations which have been ranked in order of size is equal to the value taken by the middle or the half in brackets n plus 1 observation when n is odd. So n is the number of observations. In the example that we had before, the number of observations is 10. So 10 is even. So this is not what we can use if we are to identify a median from that set of observations, because this applies when the number of observation is odd, but there the number of observations is even. So it is half the sum of the values of the two middle observations, that is the half nth and half n plus 1, when n is even. So if we consider the example that we had, that means we would be using this, because there the number of observations is 10, which is even. So we have an example here. How many observations? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. This is even. 22 is even. They are not arranged yet in order. But before we identify the median, we need to rank them. So you rank the data in ascending order from the smallest to the largest. So the smallest is 5. There are 3 5s up to 84. So because this is the size of the number of the observations is 22, which is odd, which is even, sorry. That means we're going to use this second formula to identify the median. So when we rank, then we pick the two middle numbers because the total number of observations is even, that is equal to 22. So the two middle numbers are 26 and 28. The average of these two figures is the median. So we take 26 plus 28 divided by 2, we get 27. So our median is 27. Then we move on to the arithmetic mean. This is another measure of the center of observations, and I can tell you that this is very highly used. And when we go with advanced studies in statistics, you discover that this is the most used quantity, because it has so many other features which apply in many settings when we study our statistics in advanced modules. Like the median and maybe the other one, the mode, those ones, they do apply in special cases. So the arithmetic mean of a set of observations is the sum of the observations divided by the number of the observations. Sorry. So the mean of a sample data set is denoted by X bar, or it could be Y bar. If X is representing observations, or Y is representing observations. The mean of a population data set is denoted by mu. So this notation here is a Greek letter mu. Mu spelled MU. MU, that's mu. An example here. So the following data are journey time times of college students from their place of residence to college. So maybe somebody is walking from Chikanda to here, somebody is walking from the housing hostels to here, or from wherever they stay to this. So you collect these observations, 1, 2, 3, 4, 5, 6, 7, 8, 9 students. You collect how many minutes they spend, each student spends to reach campus. So the mean, if we want to look for a figure that represents how many minutes on average that a student takes, then we have to add all of these observations, divide by how many they are, which is 9. And that gives us 21 minutes as the mean time for the journey. I think let me temporarily stop here, and then we'll proceed with the mean or median of grouped discrete data.